In these problems, we're using something called the remainder theorem to do some very useful work. We want to find a value of this polynomial function. We want to find p of -3. And the way you might do that normally is take -3 and plug it in. But when you've got all these big powers and all these terms to add together, that's a lot of work. What the remainder theorem says is that if you divide this polynomial by this number using synthetic division, what comes out in the remainder column is actually the answer, is actually p of -3. So let's give that a try. And actually, before I set this up, the only thing you'll want to be careful of is we're missing an x to the 4th term, and we're missing an x term. So you want to put zeros in there when you set it up. You can't leave those spots blank. So let's write the coefficients here. We've got 1, 2, 0, 6, -4, 0, and 40. There's our remainder spot, and we're dividing by -3. So 1, -3, -1, +3, -9, that's a -3, that's a +9, so that's 5, that's a -15, and that's going to be a +45. So we have 85 in our remainder, and that is p of -3. You can go ahead and plug in -3 and crunch that out and check it. It should come out to 85. Now this problem also asks us to find the quotient polynomial that leads to the remainder. That's this guy down here, and we can convert that back to a polynomial. You can know that this is going to start with x to the 5th because we've divided by one factor, so it's going to be 1 degree lower. Or you could count from the constant here, constant x, x squared, x cubed, x to the 4th, x to the 5th. And then we'll just put these coefficients with our terms. So x to the 5th minus x to the 4th plus 3x to the 3rd minus 3x squared plus 5x minus 15. So that's our quotient polynomial. Let's try one more. This one is pretty similar. The only difference is that actually we're finding p of -1/6, so we're dealing with a fraction here, which adds just a little bit of work to it, but not too much. Let's set it up. Again, we're missing a couple of terms here, the x cubed and the x term, so we'll put in zeros for those. And then we'll divide by -1/6, so that's -5/6, and that's a +5/36. And then I'm not going to show all the work here. We convert the -5 to 36 and do the addition here, and I think you get -175/36. And multiply that by -1/6, we get 175 positive 216ths. And multiply that by -1/6, and you should get -175 12/96. And then when you do the addition there, I think you get 9,247 1,296. You might want to check my math on that one, but I think that's correct. And that is our value of p of -1/6. So that's a little bit about using the remainder theorem.